let's continue talking about critical thinking and doing cannabis research and how do you do good research? So what makes a good experiment? Number of things. A good scientific study, you have to carefully design it, and it has to be clearly defined without ambiguous terms. It has to be properly controlled and as unbiased as possible. So in order to do this, here's a list. You want to ask very specific questions, use precise, unambiguous language. You have to consider who your population is and how will you find your answer? What is the appropriate method of investigation? You have to use valid and precise measurements and make sure your study is safe and ethical and unbiased. That's tough. You want to maintain your objectivity and then consider when you hear your information, how well was it vetted? So let's go through many of these. First of all, you have to ask specific research questions. High quality research, you have to be as unambiguous as you can. And a term is considered ambiguous if its meaning is left uncertain, if it's open to interpretation, if the word could mean something different to you than it does to me. So here's an example. Is marijuana safe? That is a worthless question because it doesn't seem ambiguous, but is so ambiguous. What do you mean by marijuana? How much? So are we talking, a hit off a joint, or are you talking 1,500 pounds? And when you say marijuana, do you mean whole flower? Do you mean an isolate? Do you mean CBD? Do you mean THC? Do you mean that you're vaping it? Do you mean you're eating it? Why are you taking it? When are you taking? Who is taking it? What kind of cannabis is it? Is it a hybrid? What kind of strain is it? Is it a safe source? Who is taking it? So how old are you? Do you have any contraindications? Do you have psychosis or a heart condition? And when you say safe, what do you mean? Physically safe? Psychologically safe? Even societally safe? So I just spewed a whole bunch of different questions from 3 words. And that's what you have to do when you analyze a scientific paper. You can't just throw out a statement like, is marijuana safe? You have to get very precise. So a better question would be, what is the ratio of the lethal dose to the therapeutic dose of a 50 milligram dose of THC? I mean, that's much less, exciting sounding, but that's what you need to do to get at the meat of it. To do good research, you have to clearly define your study population and sample. So what the population is, that's the group you want to investigate. So maybe you are curious about the effect of cannabis in postmenopausal women. You can't study all postmenopausal women in the world. You just can't. We're grumpy. We're not going to answer your questions. So you're going to find a sample, a subset of those individuals. So you may pick 3,500 or 300 or 30 postmenopausal women. That's your sample. It's your subset of your target population. And do you have a good size? You don't want to just ask, 3 people. You want to have a decent number that will give you your answer. Now, for some studies, it's still pretty small just because you're limited by the expense of the research. Surveys, you can get a larger number, but you need to consider that. And when we're getting our sample, there's different ways. You can have what's called a probability sample. That uses some form of random selection. So everyone in the group has an equal chance of being chosen. Now one of the best ways to do this is something called representative sample. Let's say my sample is postmenopausal women. Well, my population is postmenopausal women. My sample would represent American postmenopausal women. It would have the same race and orientation and size and all that. It would represent those women. It wouldn't just be the women who happened to show up and as they were walking down the street and I yelled at them to come be in my experiment. So it would represent my population. A non-probability sampling is participants aren't chosen randomly. This is much more common. This we might see a convenience sample. That would be, you're a student in my class and I make you do my research. You can't actually do that, but I make you do some research. You're a convenience sample. I have you, you're there, but you don't represent the world. You're 20 years old college students. You're not representative. You can also have a self-selection sample. Who is going to show up to my lab to do my survey? And then we're going to have some volunteer bias. People who volunteer for a study on cannabis don't necessarily represent the world at large. Another thing you want to do good research is your measurements, they should be valid and they should be precise. And it's a difficulty, it's a problem with cannabis research today. And I'm not blaming the researchers, it just is very difficult because you can't really do a clinical controlled study, especially because it's Schedule 1. What we often do is we ask people about their cannabis use. But how much precision can we get? How much cannabis do you use? Well, what are they using? All those same questions. What are they using? And what is the ratio? And what is the chemovar? And how much are they using? And what route of administration? And all of those things matter. And you can't really compare somebody who's doing a vape of pure THC of 50 milligrams of pure THC to somebody who had a 2 milligram edible. It's not the same experience. So you have to be valid and precise in your measurements, and that can be particularly hard with cannabis. Now, how reliable is your experiment? We look at something called internal validity. Can you be sure that this drug caused the effect you're looking at? So we gave cannabis and people's anxiety went down. Did cannabis necessarily do that? And I'll talk more about this. And we look at external validity, which is how generalizable are the findings. So internal validity is the degree to which a design lets you be confident that it's a causal relationship, that this caused that, between the independent variable caused the dependent variable. And you have to look for confounding factors. Are there other things that might have caused that effect rather than the cannabis? So I have a patient who has anxiety. I'm a psychologist, and let's just pretend. And I recommend cannabis for anxiety. And she comes to my office and we have therapy sessions and she's taking cannabis. And over the next 6 weeks, her anxiety goes down. Well, how do I know it was the cannabis? We can say the cannabis caused that, but maybe it's because she's in therapy with me and I'm a marvelous therapist. Maybe it's because something changed in her life over these 6 weeks. So how valid is it internally? How can you be sure that cannabis caused the decrease in anxiety? You don't want to confuse correlation and causation. Just because two things occur together, they're correlated, doesn't mean one caused the other. So don't confuse correlation with causation. One of the classic examples is, I'll go to this one right here, you can read the others. When ice cream consumption goes up, murder rates go up. Does that mean that ice cream causes murder? Maybe you get, those cold headaches and it makes you stab somebody. Or maybe murder causes ice cream because they're correlated. Maybe you kill somebody and you want to celebrate with ice cream. Or maybe in the summer, people eat more ice cream and the heat makes people mad and they kill each other. Don't know, but just because two things are correlated doesn't mean one caused the other. External validity. How well can you generalize? How well can you say, well, this happened in my lab, that means it's going to happen in the real world. So I give cannabis to a rat and I get X result. Does that mean I will necessarily get the same result in humans? I might, but I might not. So can I replicate this study? Can other labs do it again? And can it be replicated in the real world? Finally, for good research, you want to be as objective as you can. You want to try and keep your confirmation bias low. Confirmation bias is we tend to look for things that support the way we already feel. So if I'm a scientist and I truly believe that cannabis is harmful, and I'm going to interview people who have smoked cannabis, I may unconsciously look for evidence that supports my point of view that it's harmful. I may interpret somebody's answer that's kind of ambiguous, but I may interpret it based on my preconception. And we all do this to some degree. So I'm going to have you analyze and evaluate a pro-cannabis article and a negative cannabis article. And we tend to find it easier to rip apart the articles we don't agree with. But the ones we agree with, it's like, yeah, that's a good point. So confirmation bias, we all have to fight that. We all also want to look at the source of where we found this information. Was it on Fox News? Sorry for Fox News fans. Or was it in Cosmo? Or was it in some very biased source? Ideally, you want to find the primary research article, and it should have gone through peer review. So other scientists should have looked at it. So is it published in Nature? Or Scooter's Way Cool Journal of Sciencey stuff. Consider that. Now I have in your notes, I've listed some good sources of information for cannabis. There's some books and a couple of websites. I love Project CBD. It's marvelous. They're really pretty up to date. They have some good science in there. Healer.com, Leafly is good. Prof of Pot. So there's some good sources to look for. And as part of one of your projects this semester, you'll be analyzing web pages. All right, the last thing we're going to do for this section, we're going to talk about fallacies of reasoning. And we'll be looking at some articles I give you, and we're going to look for these fallacies. And it's also a source of extra credit for the semester. So that's described in your syllabus. So let's look at some what we call fallacies of relevance. An ad hominem argument. That is when somebody attacks a person rather than addressing the facts. Senator Latham gave a speech about the failure of the war on drugs, but he smoked pot in college, so he's clearly biased. All right, what we're doing is we're trying to address the argument. He gave a speech about the failure of the war on drugs, but some guy who's arguing with him just said, oh, well, you smoke pot. He's not addressing the argument. He's ignoring the issue. So these fallacies of relevance are going to be arguments people give you, but they're not even talking about what you're talking about. They're talking about the fact that this dude smoked pot in college. So Willie Nelson is very pro-cannabis, but I don't like his music. I do, actually. So that would be an ad hominem argument. Can we address the issue he's talking about, not the fact that you don't like braids? Okay. Other ad hominem arguments might be attacking the motive. Dr. Allen gave a talk about the benefits of medical cannabis, but he just wants to make money off his patients. Well, maybe he does, but it doesn't mean his facts are incorrect. Address the issue. As I said, fallacies of relevance are arguments that look at something else. They're not looking at the issue at hand. Another fallacy of relevance is called an ad populum argument. 4 out of 5 dentists agree. Most Americans drink, therefore alcohol is harmless. Just because most Americans agree on something doesn't mean it's true. There's a lot of people who now think the earth is frickin' flat. There's a lot of people who think vaccines cause autism. Just because a lot of people think something doesn't make it true. An appeal to emotion. That classic way before your time commercial. This is your brain. This is your brain on drugs. And they show an egg sizzling in a pan. Any questions? Even back in the 80s, that bothered me. Yes, I have many questions. What does an egg in a pan have to do with my brain? This adorable puppy is named Fluffy. Fluffy is trapped in a cage at a pharmaceutical company where he receives daily injections of a potentially dangerous drug. Please stop the monsters who torture puppies and vote to ban animal testing. All right, the issue we're talking about is animal testing, apparently, but we have gotten no facts on it. All we have is an appeal. Puppies! You can't hurt puppies. All we have is an appeal to emotion. We've used strong words, monsters and adorable, and there's some torture, strong words, but I have no facts about animal testing. Circular reasoning. That's when a conclusion is supported only by itself. This is bad because it's wasteful. It's wasteful because it's bad. And the example from my life, I remember when I was 9 years old and I was driving with my dad, and it was at night, and there was lights on. There was lights on a tower. And I said, Dad, what are the lights for? And he said, so the planes don't crash into the tower. And I said, well, what's the tower for? So, oh shoot, what's the tower for? To hold up the lights. That's what he said. That's a circular reasoning. Another fallacy of relevance is a red herring. That's going to be you're diverting your reader's attention to just another issue. Many people claim that medical cannabis helps people with pain, but what they don't realize is that most of the packaging that cannabis comes in is made of non-recyclable materials, and it's hurting our environment. All right, the issue at hand is medical cannabis and analgesia. He's talking about recyclable materials. That's important. Let's talk about it. Not now. Let me deal with my issue of cannabis and pain, and then we'll talk about your issue. You're diverting the attention. Democrats were critical of Richard Nixon's drug policy, but Bill Clinton lied about sex. True, both true. Let's talk about the issue at hand, then we'll get to your issue. That's a red herring. Searching for perfect solutions. If a solution we're saying it doesn't deserve support unless it completely eliminates the problem. There's no point in drug education programs because some people will still do drugs. Okay, 1% are going to do drugs. That means let's throw out the whole thing. Or we should not approve the use of medical cannabis because some people get anxious when they use it. That is true, but a lot of people find relief. So searching for perfect solutions means if something is not 100% perfect, which nothing is, then we should throw it out entirely. The next few are fallacies of insufficient evidence. These are going to address the issue at hand, but they do it in a not very good way. An inappropriate appeal to authority. It's also called an appeal to inappropriate authority. We're citing somebody, but not a really good authority on the subject. Snoop Dogg says marijuana is not addictive and has no side effects. Okay, Snoop Dogg's used a lot of weed, but I would rather get that information from a scientist, from a physician, from somebody who has studied it. So Snoop Dogg in this case would be an inappropriate authority. My barber told me marijuana is a gateway drug. Okay, is he the best source? No. And I'm going to skip this one. There's also appeals to ignorance. We can't prove that something is true, therefore it's false. No one has proven that Ritalin stunts growth in children, therefore it doesn't. No, not necessarily. That might be we just haven't proven it yet. No one has proven that cannabis, does XYZ, that means it doesn't. Not true. We're still doing a lot of research. So lack of evidence is not evidence of lack. A couple more. An either or, also called a false dilemma. When you only have two choices and that's it. America, love it or leave it. Is that my only options? I either have to love it or I have to go away? Can't I love it, some things about it, and not like other things? If we don't legalize marijuana, then everyone will be in prison. That's it? Those are our two options? It's either completely legalized or everyone's in prison? If pharmaceutical companies aren't allowed to advertise to consumers, patients will never find out about new drugs. Those are the only two options. So a lot of say you say if or. It's either to say either this or that. So an either or dilemma. Another fallacy of reasoning is you attack a position that doesn't really exist. Normal wants our children lighting up at recess. No, they don't. They don't want that. So you may say, oh, cannabis users want all our children using cannabis. No, they really don't. Let's see, there's hasty generalizations. And a lot of times you just make a statement and pull everyone into your statement. All millennials support legalizing marijuana. Of course they don't. All millennials don't support any one thing. Cannabis didn't work for me, so it's a bad drug. All right, so that's making a big generalization. Slippery slope. We'll see these next. We'll see these a lot. If we legalize marijuana, then what's next? Cocaine? Heroin? Eventually, we'll just give out syringes along with our baby bottles to start everyone on drugs early. A slippery slope argument. You'll see it because it takes, if we do this one thing, then this will happen, and this will happen, and this will happen, and the world as we know it will end. It usually ends with the world as we know it will end. And finally, don't confuse correlation and causation. Just because two things happen together doesn't mean one caused the other. So when Carly was 14, she smoked pot, and now she's doing heroin. Clearly, marijuana is a gateway drug and caused the heroin. Well, maybe other things happened to Carly. Maybe that's just who she is, and nobody starts with heroin. People start with tobacco and alcohol. Those are the gateway drugs, and then are more likely to go to cannabis, and then are more likely to go to harder drugs if they go that route. Let's see. People who smoke cannabis are less likely to have type 2 diabetes. This is true. Therefore, cannabis cures diabetes. Be careful with the word cure. And it may be true. The cannabis does affect your pancreas. But does it necessarily do that? Maybe cannabis people eat differently. Maybe genetically you're more prone to like cannabis if you don't have the diabetes gene. Who knows? But just because two things happen together doesn't mean one causes the other. And as an example, this line in green is the per capita consumption of cheese over the years, and in blue is the number of people who died by becoming tangled in their bed sheets. This looks like cheese causes death by bed sheet. The number of people, who died by becoming tangled in their bed sheets in red, and the total revenue generated by skiing facilities. Very tightly correlated. Doesn't mean one caused the other. The divorce rate in Maine, and the per capita consumption of margarine. And the number of films Nicolas Cage appeared in, and female editors on the law review, on Harvard Law Review. So just because things are correlated doesn't mean one caused the other.